Section 4. Creating and deploying your first smart contract. So let's kick things off here with starting our smart contract. So about our project is going to be a simple contest dApp. So the way that our dApp is going to work here is that there's going to be a manager and a list of different participants. Each participant is going to be designed as a struct called participant, which is going to consist of a name, phone, and email. When a participant enters, their personal public key of their virtual wallet will be mapped directly to their sign-up information. So their personal address will be related to that specific participant. So the way that we're going to do this is when a certain amount of participants have entered the contest, or just really as many as they want to be, the manager is able to then randomly pick a winner and then pay out the prize amount of Ether to that winner. So the manager is the one that has some specific powers in this sense. So a high-level overview of the needed steps for this dApp and smart contract development. We want to create our smart contract first. Then we are going to migrate our smart contract to our native development environment. Then we will install our needed modules using npm and create a test suite for our contract. Then using JavaScript, we will create a way to compile and then deploy our smart contract to the Ethereum network using a custom provider that allows us to do so. Then we will interact with our deployed contract using Remix through the injected Web3 environment. So just a quick overview right here. We will fire up our Remix IDE, create our contest contract and constructor function, create variables for our organizer, participants, and a way to identify a winner, make two functions that will allow for a participant to register, and a way for the contract manager to pick a random winner from the list of participants. Then we will create a way to pick a participant from all the participants completely randomly. So let's head over to our Remix IDE. So I've zoomed up as much as I really could so you guys can get a clear view of what I'm typing over here. So already I have required and initialized our current needed version of Solidity, which is 0.4.17. So make sure that you are on Solidity version 0.4.17 and we should be good to go. So first off, let's initialize our contract. I'm going to name this contract Contest. So inside of our contest, we need to create a private address of our manager. Then we also need to create the private address of our winner. So basically what we want to do later on is we want to retrieve the address of the winner specifically. We don't care about the other addresses. Next, what we want to do is we want to define a Boolean that will return true when a winner is picked. And just set that directly to false. So now comes the time for our struct. Our struct is going to be for a specific participant. And when a participant registers for our contest, we want them to sign up using their name, phone, and email. So these three properties of a participant will be all strings. Next up, let's create our constructor function for the contest and set the manager directly to the message.sender. So automatically, whoever deploys his contract will be the manager. So now what we want to do is we want to create a mapping to specifically assign the address that the participant is on who signed up to that specific participant's credentials. So to do this, we're going to create a mapping and then we're going to use a small arrow function here to assign that address to that specific participant. And this is going to be private, of course, because we don't want everybody's information to come out. And we're going to call this participants because this is actually going to take into account multiple participants in this mapping. As you may recall, mapping is very similar to just really iterating over an array. So yeah, this is basically why we're calling it participants, because this is multiple different participants. And then we're going to define an address, which is going to maintain all the participants in the address list. So we're going to define a specific address array here. And we're going to call it participant list. So now we are ready to head on over to our registration function. So let's define our first function here, which is going to be called, you guessed it, registration. We want this function to be a public payable function. And it's going to take in the arguments of the name, phone, and email of the participant. So now inside here, we're going to use a require function to require a certain amount of ether for the registration to commence. So the reason why we want a certain amount of ether is because we want the contest participants to provide us with some sort of minimal contribution to basically fund our contract. So obviously when you enter a contest, specifically a lottery, it's not always for free. You have to pay some money to get that lottery. And basically you're pretty much taking a gamble here to see if you can win the big amount of money here. So this is very similar to a lottery in a sense that you're going to have to pay a certain amount of ether. So we're not going to make it a whole lot of ether here. So we'll just make it about 0.00001 ether, about 4 zeros in front of that 1. And we also want to check and make sure that the winner has not been selected, because if a winner has been selected, then you don't want any more people to sign up for your contract. So just make sure that that there is false. So now we're just going to assign the reference of our participant. We're going to use the storage right over here to be a lot more efficient here when storing memory. And now under here is where we're going to start assigning the argument values to our participant that we have just defined over here in right next to our storage. And then finally next, we're going to push the new instance of our participant to our participant list by pushing the message.sender. And then finally, we're going to send the amount. And just a quick note, but this function has not been created yet, but we will be creating it later on. So now we have a way to register the user and then also send the amount directly to the organizer. Like I said before, the send amount has not been created yet. We will be covering that in the next video. So next up is what we want to do is we want to create a way how to pick a winner. So let's define that function next. And we'll make this function here public. So now inside here, we're going to check the sender address and make sure that should equal the manager, since the manager should only be able to pick a winner. So we're going to use another require here. And then underneath that, we're going to randomly select one participant among all the participants. So we're going to make a uint of the index. And we're going to retrieve it from the random amount of participants. Then next, what we will do is we will take the winner address and then assign it to the participant list. And then finally, we want to change is winner selected to true. So as you may have also noticed here, random by our error over here has not been yet defined. So just similarly to send amount, we're going to define this later on. However, random we're going to define soon in this video. So next, let's create a way how to transfer that amount. So by transfer amount, this is not going to be the same thing as send amount. This is going to basically just send the amount ether that is going to be needed to send to the winning address. So this is not just to send the amount to enter the contest. This is actually like transferring the specific amount to the specific winning address. So this is really just for the winning address only. And we'll also make this a payable function. So now let's check and make sure that the ether is greater than that really small amount that we had before, about 0.0001 ether. So basically the contract manager is going to have to send a specific amount of ether as the prize ether. So possibly maybe this was a specific lottery here where the winner can win a certain amount of ether, and the participants knew this and they entered in and they were all trying to win this specific amount of ether. So the contract manager is responsible for paying this out. Now, security-wise, this isn't really the most efficient way of how doing things, because the manager could also fraudulently just send out any sort of ether here. But perhaps maybe the require function here that we're going to define is making sure that the payable amount of ether has to be greater than a certain amount of ether here. So that basically makes sure that the contract manager is responsible for paying out a specific amount of ether here, greater than that amount. You can also set it equal directly to that amount of ether to make sure that they are specifically paying out that amount of ether. But in this case here, because it's just for testing, we'll make it have to be greater than a small amount of ether in a sense. And we'll make it a little bit bigger than our previous required amount of ether. And we also want to make sure that the message.sender is indeed the manager. And we also want to require that a winner has indeed been selected. And then finally, we want to send that amount. So we're going to be using the same function that we will define later on. But this is specifically for the winner address, as you can see over here, only. So now one last thing to do before we just end this video is we want to define the random function. And the random function is going to be used to retrieve a certain number randomly from the participant list. So this is a very special function in the way that things are going to be done here, and Solidity, as you probably have seen before in section 2, is a very different language. It's a very strongly written language here. So try to follow along with what I'm going to be doing here in order to retrieve a random number here. And this is basically needed in order to retrieve really any sort of random value in Solidity code. So let's define a new function here called random. And now inside of random, we're going to return a UN. So now we're going to call kekak256. And what kekak is going to do is it's basically what's going to generate this random value. We also want to take into account the block difficulty, pass in the now as the time frame, and then the participant list. And I had a small spelling error over there. And there we go. So right now this random function over here is going to return this UN. kekak256 is basically used to help generate a random value here. The block difficulty, as you probably have learned in section 1, is what is going to depend upon the mining process and how difficult the block is to mine. The now here is the time frame, and then we're going to take into account here the participant list. So right now the only errors that you should have are related to the send amount, and that we're going to be covering and creating in our next video.